Okay, so now we have our spindle drive installed. Okay, fine, it's still a little out of skew, but we can fix that later. To power it, this is a variable frequency drive. Amazingly enough, it has a rather extensive manual that goes with it. It might look thin, but there's lots of information packed in there. I'll undo the bottom and we can all have a look inside. Right, so we've opened this puppy up and there's a lot of connections. For the basics, you can use this keypad to spin the motor up and stuff. So for the moment, obviously the motor is going to plug into there. I have some cable to sort of do that with. I'll do a good job of it. And 240 volts gets plugged in here somewhere. Now, it's all in the manual, so I'm going to have a read, and then I might start hooking it up. A couple of bits and pieces. So apparently you can control this from the breakout board. So this is the parallel port board that plugs in the computer that controls everything. So I'm able to use this with Mach 3. The only problem is this has a 10 volt input and the breakout board only has 5 volts. No issue there. We use a voltage multiplier and we can get a full 10 volt range. And the other bits and pieces on here, I'm not sure, but I think it has a relay for cooling system and stuff like that. Gonna have a bit of a squiz to see what that's all about. If it's true, then I can probably run the fan and pump arrangement off this. So if I put them in series, that might take care of our little 12 volt to 24 volt problem. Having said that, I do realize they are different loads. Alright then, I think that's about all I have to say for the moment. We'll see what we can do. Rightio, so I've connected a little 10 amp cable to this. Apparently, from what I've been reading just in here, this is like a 3-phase setup, and it'll take 2 phases as well. 2 phases will plug into any of these. So that's what I did. Well, let's switch her on and see if she works. I've just powered it up. There we go. Oh, good. There's some sort of error on there, but well, that means it works. Well, that's good. Now I'm going to wire in our motor. For that, I have a nice long, 2 meter long 10 amp cable. We've got a fitting. Yeah, so I'll film again once I've done that, and we can see if we can make the motor turn. Well, we've got it all wired up. So the motor has its little fitting with a 2 meter cable that I can sort of like route elsewhere. Here we go. This is sort of like the setup we have now. I have done a little bit of wiring to get this thing working. All the controls are on the board. I have a potentiometer, but I gotta wait for my soldering iron to heat up. But for the moment, from what reading I've done, I can use the control panel here to get things running. Now let's see. There we go. Alright, so this means it will be set for 100 Hertz. So I press run, and the motor fires up. Maybe I'll hear it. If I slow it down, yes, and as we can see, 100 Hertz, and if I scroll over, revs per minute is 288. Nice. Does a whole bunch of other stuff I'm not familiar with yet. Let's see. Alright, now if I sort of jog over here and slow it right down, what are we doing? We should be able to go through it. There we go. Let's make that 5. and I'll make that 0. Here we go. Might be a little easier to see. Yeah, the camera can catch it spinning now. And that's pretty strong. I could probably stop it if I really wanted to. But yeah, when you're milling stuff with a motor like this, you don't want to be running it this slow. Larger motors would probably fare very well. But yeah, I'm very happy with this. It's starting to get, I'm not going to say hot or warm at the moment. It's sort of, put it this way, it's not as cold as this, but it's still a little cold. Alright, well, that's what I've got so far. I'm going to hook up that, press stop and she switches off. I'm going to hook up that potentiometer and see what I can do with that.